So today we're going to be talking about domain and range. I'm going to go through a couple of example problems with you, and we're going to be discussing how to write domain and range. So one of the things we have to remember when we write our domain and range is there are two different ways we can actually write them. The first way is if the data is discrete. So if the data is discrete, then the data cannot be broken down into decimals and fractions. A lot of the times, discrete data are variables that we say that we can count. There's also continuous data. So if the variables are continuous, then these are variables that can be broken down into decimals and fractions. And a lot of the times we say continuous variables are things that we are trying to measure. So before we get into domain and range, let's go ahead and review discrete and continuous data. So here we have some examples of the differences between discrete and continuous. So for examples for discrete, those are variables such as number of books in a library, number of candy bars sold, number of kids in a classroom, and number of tickets sold. So these are all items that we are counting. So if we were to go purchase a ticket, we're not going to buy half of a ticket. We're going to purchase a whole ticket. Or if we're counting the number of books in a library, we're not going to count half of a book. We're going to count all the books as one whole book. For continuous, the variables include time in a race, temperature throughout the day, cost per pound, a person's weight over time. So these are things that we are going to be measuring. So cost per pound. So for example, if you go to the store and you buy chicken, a lot of the times the chicken says, oh, it's $2 per pound. So you can buy a pound and a half, a pound and 3/4, and so on. You can also measure temperature throughout the day. So at 1 o'clock, the temperature was 70 degrees outside. At 1:30, the temperature was 72 degrees, and so on. Also, if you look below discrete and continuous here, I have showed you different types of graphs. So for the discrete graphs, we notice that the data is kind of scattered or the data is not connected. If you look at continuous graphs, your data is all connected and it's being measured and continuously going through. So now that we've reviewed the differences between discrete and continuous, we're going to go ahead and work on two example problems. Now with those example problems, we will be writing the domain and range for each of them. And that domain and range, how we write them, is going to be based off whether the problem is discrete or if the problem is continuous. So our first example problem reads, Claire plans to sell cupcakes to raise money for her cheerleading dues. She buys $20 worth of cupcake supplies and plans to sell cupcakes for $2 each. So our first step is to identify what we are comparing, which would be our independent and our dependent variable. So if we look, we know that we are going to be comparing the number of cupcakes sold versus how much money she earns. So our independent variable is going to be the number of cupcakes that she sells, and our dependent variable is going to be the money earned. So because we are selling cupcakes, we don't really want to sell a cupcake as a half. We definitely want to sell all of our cupcakes as whole. So because we are going to be selling a whole cupcake, our data is going to be discrete. So let's go ahead and set up our table. So if Claire does not sell any cupcakes, so that would be 0 cupcakes, we know that she at least spent $20 on supplies. So that means she is negative $20. Now, we also know that she plans to sell the cupcakes for $2 each. So let's say Claire sells a cupcake. She's earned $2. So we're going to add $2, which makes negative $18. Let's sell another cupcake, 2 cupcakes. We know we're going to add another $2. So now Claire is at negative $16. So as long as Claire keeps selling cupcakes, we know that every time she sells, they're going to be $2. So we're going to keep on adding $2 every time. So that would be the table. So let's look at our graph. So if we look at our graph, we can actually see over time, every time she sells a cupcake, she is adding another $2 to her money earned. Therefore, by the time she hits 10 cupcakes, we know that she breaks even. So really, by the 11th cupcake she sells, she finally actually makes $2. So let's go ahead and start practicing how we would write the domain and range for Claire's problem, since we know that this is discrete data. So when we're talking about domain, we know another word for domain also is going to be independent variable. So I'm going to go ahead and underline independent variable. So we know that our domain is actually going to be talking about the number of cupcakes. So I'm going to circle domain in my table. I'm also going to circle it on my graph. So I know that I have to be talking about the number of cupcakes when I write the domain. So our domain for discrete is going to be x equals, since those are our x values, we know the number of cupcakes she sold. She started with 0 cupcakes, 1 cupcake, 2 cupcakes, 3 cupcakes, and so on. So our domain has to be showing the number of cupcakes that she sells. Now for the range, another word for range would be dependent variable. So if I look up here, I know that my range has to be talking about the money that she's earned from selling her cupcakes. So in my table, that would be her money earned. And on the graph, that would show the y-axis here. So when I write the range, I know that all the numbers in the range have to be representative of the money that she's earned from the cupcakes. So I'm going to start with the lowest amount of money she's earned from selling, which is her negative $20. Then we have negative $18, negative $16, and it goes on until she runs out of cupcakes. So when we have discrete data, we are going to be listing out our domain and our range. So now let's start with example 2. So this one says, Rudy is running the 100-meter race at his school's track meet. Rudy starts the race at the 5-meter line and runs 10 meters per minute. So again, our first step is to identify the 2 variables we're comparing, the independent and the dependent variable. So I know I'm going to be comparing the meters per minute in Rudy's race. So now I have to decide what is going to be my independent, what will be my dependent variable. So our independent variable is going to be the time in minutes, and our dependent variable is going to be Rudy's distance in meters. So because we are talking about time versus distance, I know that I would be able to figure out where Rudy was not only at 1 minute, I would also be able to figure out where he is at 2 minutes, 2.5 minutes, 3 minutes, 3.25 minutes, and so on while he is running this 100-meter race. So because of that, we know that this problem is going to be continuous. So let's go ahead and set up our table based on the independent and dependent variables. So we know Rudy starts at the 5-meter line when he begins his race. So at 0 minutes, he's at 5 meters already. We also know that he's going to be running 10 meters every minute. So by minute 1, we are going to add 10 meters. So now Rudy will be at the 15-meter mark. At 2 minutes, we will add another 10 meters. So now Rudy will be at the 25-meter mark, and so on. So Rudy ends his race at 100 meters. So now let's look at the graph of Rudy's race. So if we look at our graph, we know that we can see that at 0 minutes, he does start at the 5-meter mark. And every minute, the graph is also adding 10 meters. Now, since Rudy runs a 100-meter race and the graph continues on, we know that he actually stops at 100 meters. So let's go ahead and put that stopping point on our graph. So we know that it's somewhere between 9 and 10 minutes. So we know it's actually going to be at around 100 meters. Will be at around 9.5 minutes. So let's go ahead and start practicing the domain and range for continuous data. So for Rudy, his domain is going to be our independent variable, which is going to be minutes. And if I look at my table, I know that this is going to be my domain for minutes. And if I look at my graph, I would be looking at the x-axis, time in minutes. So when I write the domain for continuous, I need to find the lowest time that Rudy starts his race at. So the lowest is going to be at 0 minutes. And then I also have to figure out, well, for 100 meters, how long did it actually take him? And we said that that took him about 9.5 minutes. So really my domain is only going to go from 0 to 9.5 minutes. And I could find all of the time in between 0 and 9.5 minutes to see where Rudy was at during his race. Now it's the same thing for the range, but with the dependent variable. So our dependent variable is talking about his distance in meters. So in the table, we're talking about his meters. On the graph, I need to be paying attention to the y-axis. So when I write the range for continuous data for Rudy, I need to make sure that I'm talking about his distance in meters. So the lowest distance Rudy starts at would be at his 5-meter mark. And we know that the race actually only goes up to 100 meters because that's what it said in the problem. So we know our ending point is going to be 100 meters. And since range is talking about the y-axis or the y values, I know that Rudy's distance is anywhere between 5 meters and 100 meters. So you will be using this lesson during week 2 of distance learning. If you have any other questions about domain and range, I have added some anchor chart notes as well, so make sure to look for those. If you have any other questions or any ideas that you would like to give me, go ahead and message me through our Google Classroom. Have a great week.